Hello everyone, how are you doing? I am going to give a quick demo on machine learning. Hope this demo will help you to do your projects on machine learning. So, what is machine learning? Machine learning is nothing but a process of inducing intelligence into a system without explicit programming. Let me show you a demo quickly. Okay, so this is a small code in Python. I have written in Python. So I am having three variables: okay, age, number of hours studied, and average past mark or past score. Okay. So what we are going to find is, suppose a student who learns for a particular semester, right? If he has studied for more than 120 hours, right? And if he has scored more than 60 percentage in the past exams, he has a probability of passing the current exam. So suppose we try to write a small program in Python. This is how we will write. Declare three variables, or you get the input from the user: age, number of hours studied, previous score, and then I have written a if-else statement. So this is the logic, right? So if the age of the student is more than 17 and less than 23, and if the number of hours he studied is more than 90, right? And for this semester, and if the average passed score is more than 60, then I am declaring him as pass, right? If any of this condition fails, he's going to fail in the exam. I execute this code, and I'm going to print the result now. Now his age is 17. He has studied 120 hours, but his previous score is 59. Let's see what the result. Mm, So it's fail, obviously, because this condition is not satisfied, right? If the average pass score is greater than 60 only, he is going to clear the exam. Otherwise, he is going to fail, right? So what if I uh, change the input to 64, and again I execute this one, and then our code uh, now is result is pass, right? So what we are doing here, so we are writing a if else statement, right? So we are checking the conditions. If this condition satisfies, then execute this statement, and if this statement execute if this condition is satisfied, then execute this statement. If this condition is not satisfied, go to the else block, right? If this condition is not satisfied, go to the else block. If this is not satisfied, then go to the else block. Like that, we have coded the logic, right? And then this is our data. This is the given data, and this is our logic. This is regular programming, so not a big deal, right? So whatever logic you want, you will do the code for the given data. It will execute your logic, uh, and then it will show you the result, give you the result. That's it. So what if you want to try this thing, machine learning, without explicit coding? This is what explicit coding, right? This block is the logic. So what if he studied only 50 hours, and his past score is 80 percentage, right, in the previous exams? But our code will show he is a failure, because our condition is more than 90 hours, right? So what if we are going to give the input as 50, and his past score is 80, right? Again he's going to fail, even though he scored well in the previous exams with very good marks. Our system is going to show he's a failure, because this is the condition we hard coded, right? So but if you apply this to a machine learning algorithm, it will handle these conditions, and it will predict the exact score based on the weightage, not by having an explicit condition. Okay, let's see how we are going to do it using a machine learning code. Okay, this is a small machine learning hello world application. Okay, so I have an import section. Don't worry about it. We are using Keras and TensorFlow framework. Again, it's a Python code. Just importing that, and I am preparing the data. So this is the data, right? We have declared, right? Base. So we are randomly assigning the age, previous score, and the result, right? We are giving the data and then the result, pass or fail, right? You are going to provide it in the label. Whether if one means pass, if zero means fail, and this is your input data. So in the input data, we have two things. One is the training data. This is going to be our training data. This is our test data. I'll tell you what test data means, right? So right now in the training data, we'll have 1,000 records with 3 columns, right? So what are the 3 columns? Age, number of hours studied, and the past score, right? This is our one row in the 1,000 record, right? Each row will have these 3. That's why we have 3 columns using NumPy and prepare the data. So if you want, I will show you a small how the data is prepared, right? So this is our train data. Let's see what it is. So this train data matrix has 3 columns. Array has 3 columns. One is the age, other one is the number of hours studied, and this is the previous score, past score, right? Similarly, if you want to see the test data, so what is test data? We are going to have only 5 rows. Here you will have 1,000, but this one has only 5. Okay, so see, only 5 rows we have. We have prepared the data now, and after preparing the data, now we are going to prepare the labels as well. So labels are nothing but the result. For this input, you executed this code and you got this result, right? Fail. So in machine learning, what you will do is you will provide the data and the result as well to train the model, right? Both the things you will give, and this algorithm is going to prepare this part for you. You got it, right? In normal program, you give the data, you give the code, and your program will give you the result. But in machine learning, what will happen is you will give the data. You are going to give the result also to the, we call it as a model. We are going to give these 2 things to the model. Okay, we are not going to write this part. This part is not written by us. In the case of machine learning, the model will take care of that part for you. Okay, we're going to prepare the label. Once we prepare the label, we have the data, training data, and the label also, right? So again, this has the 1,000 rows of 1,000 records, right? Here we have 1,000 data, and for those 1,000 records, we have the corresponding results. So both of them we prepared, right? If you want to see, I will show you what is in labels. See, this is the label. See, we prepared a label which has a random value, ones or zeros. So now we have the data and the result, right? Now we are going to create something called a model. So what is the model? Model is nothing but a artificial neural network, right? ANN, artificial neural network. It's a collection of nodes, right? It's just a single function you are calling in Keras framework that will create a model for you. And once you created the model, you have to have a lot of layers, right? This is your input layer. Input layer has 5 nodes, and the shape is 3. 3 means what? Age, number of hours studied, and the previous score, right? And this is something called a ReLU. We'll see slowly what these things are. But right now, you just don't care about these things. Just have this thing and execute this one. So we are going to create a input layer. Now the input layer is created for us. And 2 more layers we are going to create. hidden layers, right? So one hidden layer has 4 nodes, and the output layer has only one node, called as the output layer. It's not a hidden layer; it's an output layer, right? So we have one input layer, one hidden layer, and one output layer. We just created an instance for this, and now we are going to attach this layer to the model. Okay, so how you will attach? You just call the add method, right? So, and this has to be named as output. Okay, so first I'm adding my input layer, and then I'm just adding my hidden layer. I have only one hidden layer, and the output layer uh, I'm just going to add. Okay, so that's it, our model, and then defined our neural network structure, and then we added all those things to the model, and then finally we are going to compile the model. Okay, for compilation we'll have something called loss function, and another one is the optimizer. Okay, right now we have something called cross entropy and Adam. Don't worry about that. So we just compile the model, and now we are going to train the model by providing the training data and the labels. For training the model, we're going to call a method called fit, right? And you have to pass data, that is training data and the labels, and epochs. Epochs means how many times this model has to be trained with the entire data. So how many times it required, we don't know. As long as your accuracy is keep on increasing and your loss value is getting reduced, you can train the model. So once you will reach a stage, your loss will remain the same, and your accuracy may be increasing, or it is also remain the same. In that case, you don't need to train the model further. You just stop the training. So initially you give some value, maybe 10 times or 20 times you train the model, and if you are okay with this accuracy, right, then you can stop it. Right now we are giving 20. Let's see how it works, right? So if you see here, the loss was more, right? First time, out of 20, first time when we executed, when we trained this model, our loss was more, right? And accuracy was less. So here you have to stop. So this is your stopping point. If you train more, right, your loss will keep on increasing, and your accuracy also will get reduced. So you have to train the model 1 or 2 times and exactly figure out where you are getting this point, where at what value, at which epoch you are getting this changeover. You are going to stop that, uh, stop training on that particular epoch. Using this data, this training executed 20 times, and this model got trained now. Everything is taken care in this fit method for you, and this model got trained now. So what is the next step? We are going to predict the output. Okay, so I have the test data, right, already prepared. So this is the test data which has 5 records, right, some arbitrary value. We are going to see how it is going to predict. So so it has predicted the result. Let me show you the result. So this is the result. So what is in the test data? So test data has these 5 records. If say for example, if the result is more than zero point 0.5, right, then we can assume that it is a pass mark. Less than zero point 0.5, we can have it as fail. Hardly we have written 20 lines of code, right, including this thing. You got a machine learning application ready. Hope you enjoyed the session. Thank you so much.